All right.
Wow, we're still using tangent.
No, it's a different kind of tangent. Not in reference. Oh, kind of in reference to triangle. All right. So, how many of you guys are in physics? So today is another scenario where your worlds are going to collide. Okay, so we're going to talk about velocity and position functions, but we're going to talk about the tangent line first. Okay, so anybody remember what a tangent line is?
It's a line that is a circle.
Okay, exactly. Okay, but instead of just a circle, we're going to be using a function. Okay, so like a parabola, or who knows what it could be. Okay, so a tangent line, no vectors today, gives the slope, which is another way of saying the rate of change, at any given point.
Levi. That was pretty good.
Well, I wrote it. Just like,
Okay, so let's say we have some kind of function like that, that's kind of weavy like that. And I was looking specifically at this point right here. Okay, so the tangent line allows us to find the slope of the function at that given spot. Okay, so if you can kind of imagine like a tangent line only intersects right at that one spot. And it might kind of touch other pieces of the function, but...
Oh, it's just a line going this way. I know we're only intersecting there.
Shut up.
Alright, so the way you find the slope of a given point is by using what's called the difference quotient. Okay, so if you want to help yourself with finds, finds slope
so
at
just find
some point. Finds the slope. Okay, so this is the difference quotient. It goes the limits as x approaches 0. Oh, that was a really bad 0.
Let's say h approaches b.
No, it's a 0, but I can't get back to my...
you said X though.
I did? Oh, h.
and
Sorry.
H approaches 0.
As h approaches 0, that's a 0.
You definitely had a P up there.
It was a scratch mark. I didn't mean to. I was trying to erase it. Anyways, of my function of x plus h minus that function of x all over h. Okay, so you probably want to star this in your notes. You are going to be using this a lot.
Is that R or N?
It's an h, dude.
Oh my god. Multi.
Pay attention.
That's why you're a math teacher.
Alright, so let's say we have some function, and it happens to be 2x squared minus 3.
Wait, so h has to be approaching 0 for this to work?
Yes, this is a definition. It cannot change. Okay, so let's say they're going to ask us to find the slope of this function at specifically x equals 1. Okay, so I'm going to ignore the x equals 1 part, and I'm going to take the function and I'm going to do the difference quotient with it. Okay, so I'm going to do the limits as h approaches 0. Okay, and the first part of this says f of x plus h. So what am I going to do with the x plus h? Good, I'm going to plug it into the x of the x plus h. Okay, so it's going to go 2, there's my x, so I'm going to have x plus h squared minus 3. Is everybody okay with just that part?
Wait, why'd you get?
No, you were right. That's exactly what I just did. Okay, so I took the x plus h, right? And I plugged it straight into there. Right? You see that? Okay, so the rest of this says now minus f of x. Okay, so minus my f of x, which is 2 minus 3. And notice that I use parentheses because if I'm subtracting a function that has more than one term, that negative needs to be distributed. Okay, is everybody good with that part? H is simply a variable.
So you just put 1 in.
You plug 1 in, no?
Yeah.
No. No, not yet. Okay, so right now I have to simplify this expression. Okay, so what do I have to do first?
Distribute.
Close, but not yet.
FOIL the x plus h.
There you go, exponents. Okay, I have to FOIL first. Okay, so I have 2. Okay, is it okay if I go straight to what this FOILs into? You guys remember how to do that? So it'd be x squared plus 2xh plus h squared. Then I have minus 3. I'll go ahead and distribute the negative through that second quantity, okay? So minus 2x squared plus 3.
Is that 2 plus h or 2xh?
xh. Okay, so now I'm going to distribute the 2 through. So that would give me 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3.
So you end up
Okay, so how many x squareds do I end up with? 0, because they cancel, right?
with, and then you also cancel out
And the 3's.
and you have whatever that.
Then you have that, yeah. So you have 4xh plus 2h squared over h.
4x plus 2h.
Okay, so good. So I can pull an h out, right? Yes, Doug?
Why in the beginning did you replace x with x with h instead of
No, this is such a big
2x squared plus h? X squared plus 3. So you replace x in the second one with 2x squared plus 3 or minus 3, but not the x with the first one.
Because that's, by definition, the difference quotient is you start with plugging in the x plus h into the first one. And then you subtract simply the f of x, which is just the x. And that's a definition, we can't change that.
When it
Wait,
gives
so
it to you,
if you go back up
says,
to that.
when it gives it to you, it says f of x of 2.
2x squared minus 3.
Yeah, and then it says add x equals 1. What's that?
Right.
Add x equals 1.
I'll show you. That's the end part.
That's what you plug in, though?
At the very end.
Well, that's
After.
what they're saying. It's like
Yeah.
add that to it.
Okay, so I can pull an h out at this point, right? On the top.
We're doing this correct. You have to pull an h out.
The greatest common factor, yeah. Okay, so at this point, what happens? Yeah. Okay, so here is something that's kind of fancy about the difference quotients. Every time you do it, once you simplify, you end up being able to cancel h's in the bottom. So one in the top, one in the bottom will always end up canceling. And if it doesn't happen that way, then you did something wrong, because it always happens. Okay?
But then that means you get
Okay, so now that I have this completely simplified, what do I do in order to find the limit as x approaches 0, or x?
Zero in X.
H.
H.
Yeah. I said x too.
X is for X.
Okay, so my slope of this function at any time is 4x, okay? So notice that it changes.
So you don't plug 1 in at X?
So now this is where I plug 1 into my x.
So couldn't you just do it all at the beginning then?
Nope.
You can't plug the X in and the H and do that equation?
Mm-mm. Okay, so this is what this means, just so you guys know. If I was going to graph the original function, the x squared, or 2x squared minus 3, okay, so this function is moved down 3. It looks something like this, right? Okay, so when x is 1, we're looking specifically at that spot right there. Okay, so the slope of that line right there, if it was tangent, that slope would be 4. Does that kind of seem like it would be 4? I'm not assuming my drawing is very good, but for a rough sketch, it would rise 4 over 1. Does that make sense, what you're finding?
So couldn't you just graph this technically on a calculator and then find the slope?
You don't, no, you can't do it that way.
You can't.
The calculator can't find the slope of a point. It needs 2 points to find it. So you have to use difference quotients.
You could just get on CAD.
No, there are other ways. Okay, so here's the second thing that they're going to do. This is question number 2. Okay, so the second thing they ask you to do is find the equation of the tangent line. Okay, so let's say they give us my function as x squared plus 8, and they're saying specifically at the x value of -1. Okay, so what is different from this question versus question number 1? You're finding an equation, not just the slope. Okay, so hopefully at this point you've noticed what kind of line have I been drawing to represent the tangent line? A straight line. A linear line. That's right. Okay, so what kind of equation am I going to have at the very end of this? Mx plus b. All right. Okay, so I'm looking for a y equals mx plus b equation. So I'm going to start by using the difference quotient and coming up with the slope. Okay. All right, so let's do that first. The limit as h approaches 0. So what do I do first using the difference quotient? Plug in x plus h into my x. Okay, so I have x plus h squared plus 8. Okay, everybody good with that piece? Okay, now I'm going to subtract my function, x squared plus 8, and it's all over h. Is everybody good? Okay, so now I'm going to simplify on the top. What do I have to do first?
You have to FOIL it.
Yep. So I have to FOIL, so that would give me x squared plus 2xh, stop it, I know, plus 8 minus x squared minus 8. Okay, on the top, what cancels?
8
Oh no, bro. Oh no, bro.
So I have 2xh plus h squared over h. Okay, I can pull out an h. Okay, now here comes the part where I can cancel. So at this point, I know that I've done this correctly. Okay, so if I plug 0 into the h, what am I left with? 2x. Okay, so the slope at any point is 2x. So to find specifically at 1, negative 1, the slope would be negative 2. Okay. That was given.
Oh, right.
Okay.
So then we'll have y equals negative 2x.
Okay, so right now, you guys, I have the slope of my equation. Shh. Focus. I know. Okay, what is the piece that I'm missing? I have the M.
Sorry.
A B. Okay, so what I need is a little bit more information. What I have here is, since I have the original function and I have an x value, I can find the point that it goes through. Okay, so since I was given my function, which was x squared plus 8, I can plug negative 1 in so that I know what the corresponding y value is. So what is the y value that corresponds to this? 9. Okay, so the ordered pair is negative 1, 9.
That's the answer.
Does that look like B? Y equals mx plus b. Okay, so right now what I have is I have a slope and I have a point to my linear equation. How could I find my equation if I have a point and a slope? Point slope form, right? You guys remember point slope form? Y minus y1 is equal to m times the quantity x minus x1, where the point is your x1 and your y1. Wow, good. So I would have y minus 9 is equal to negative 2 is the slope, and x plus 1. Okay, so I can distribute that negative 2. So I have negative 2x minus 2. And therefore, if I add 9, Henry was right that I do get 7.
How do you get
Did I get the point? Negative 1, 9?
Yeah.
So since the x value was given to me as negative 1, I just plugged negative 1 into my given function to find the y. That gives me the y. Right. Everybody good there?
So what are you trying to find? What is that?
That's the equation of the tangent line. So graphically what that looks like is if the original function was something like this, and x equals negative 1 is somewhere here, okay, so this line would look something like that. Okay, and the equation to that line is y equals negative 2x plus 7.
Why is that?
It helps you with derivatives.
Oh, okay. So just setting up.
What
Yeah.
time math use derivative?
Oh, what a good question. I actually have a really good answer for you today.
What is the point of knowing this though? Like,
Yeah, I wonder that kind of when you're like, I understand how to do the things, but I'm
mostly
like,
this specific, like, oh, I can cut the tangent of that rough, but.
Okay, so let me answer that question. The difference quotient gives you a derivative. Has anybody ever heard of a derivative? Okay, so just so you know, a derivative, the notation looks like that. Okay, so there's like a little apostrophe there. That means first derivative. Okay, you can also see it as dy dx. Okay, so those are just notations of what all this means. Okay, so this is why derivatives are so important. Okay, so let's say I have some position function. I'm almost done. Okay, so let's say my position function is s of t. Deriv, oops.
I was just wondering if it was called something different or so.
No, I totally spelled that wrong. Derivative. There you go. Thank you for catching the mistake. Okay, so let's say I have some position function, call it s of t. If I take the derivative of that, I find instantaneous rates of change. What did I find? I'm finding velocity. I'm finding speed of something.
Really?
Okay, so the derivative of your position function gives you the velocity. So I can find how fast something is moving. And if you take the derivative of the velocity function, anybody know? Where are my physics people?
We didn't do this like or something.
You did something similar to this. You found velocities and position
Yeah, we found
functions.
velocity when we were stop.
There wasn't anything associated with it?
Like the word.
Like, what do you mean, like, how to find velocity?
Oh,
Did
yeah.
you do acceleration?
Yeah, acceleration. What
So acceleration is the derivative of the velocity function. Okay, so we can find how fast something is accelerating at instantaneously.
Oh. That. Yeah, he didn't tell us about that.
Yeah.
I don't like integration.
So can I do an
What is
example of
derivative?
this? Derivative finds instantaneous rates of change.
Okay. Gotcha.
Okay. So do you guys know the position function of a falling object? Anybody know that off the top of their hands? Heads? Yeah, that's the right idea. But let's not do meters, let's do feet. So that would be negative 16.
What do we do? Feet?
So I find this to be a very interesting position function, okay? Because the idea of this is, if I throw something up into the air, I can figure out how fast it is moving at any point in time. Okay, or I could figure out exactly how much acceleration it is going at when it hits the ground. Okay, so just so you know, the t is in reference to time on this.
Is that h to
The v sub o means initial velocity,
what is the h about?
and the h sub o is initial height. Yeah, so a little sub o is initial of anything. So let's throw something into the air. Okay, so we're throwing a ball. What? An egg, a ball, whatever. We're throwing something up into the air. Okay, so if I'm throwing it, I happen to be exactly 5 feet tall, right about here. Okay, so let's say my initial height is 5. Okay, let's say my initial velocity is... I don't think I'm that good. Let's say I'm like 20 feet per second. Okay, so if I plug this information into my position function, we can find exactly how fast it is moving after a certain amount of time. So let's say how fast after, sure, 4 seconds. Okay. So, given my position function, my s of t, my initial velocity was 20. My initial height is 5. Yeah, I just plugged it in. Okay, so how am I going to find my rate of change? What am I going to do? Take the derivative. So to do that, I have to use my difference quotient.
Oh, difference quotients.
Yes, yes, yes. There you go. Okay, so the first thing I have to do is plug in x plus h. So I'm going to use x's in place of my t's just so you guys know. X plus h plus 5. Okay, so that's plugging x plus h in. And then I subtract, 20, yep, thanks. Subtract my function. All over h. Whoa, undo.
Oh.
What happened?
Wow.
That's just a child mistake.
Oh, that's weird. It's not going away. Okay, so I'll do this quickly for you guys so we don't have to spend too much time on the algebra of this. So the first thing I have to do is square the quantity, so FOIL, and then I'm going to distribute the negative 16 through at the same time, if that doesn't hurt your feelings. So it'd be negative 16 x squared. So then it would be 2xh times negative 16, so that's 32xh minus 16h squared. And then I'm distributing the 20, so 20x plus 20h plus 5. And if I distribute the negative through the second quantity, I would have plus 16 squared, x squared, minus 20x, minus 5.
Spectacular.
That's pretty good, right?
What do you find is the velocity?
Yep.
Oh, that's why I want a homework.
Okay, so my 16x squareds cancel out. My 20x's cancel out. My 5's cancel out. Do you guys notice that every time I do this, anything that doesn't have an h in it goes away?
You have negative 32x minus 16h squared plus.
Okay, so then I'm going to pull a 20 out, or excuse me, not 20, h out. Can I go straight to just simplifying that and killing the one on the bottom? So I get negative 32x plus, minus h plus 20. So now if I plug 0 into the h, I get negative 32x plus 20. Okay, so my original was 4, right?
Oh, yeah.
So then if I plug 4 into that, who's got a calculator? What's negative 32 times 4?
Negative 120. So negative 108.
Negative 108. So feet per second. Okay, so that is exactly how fast my tennis ball would be traveling.
Why isn't it negative?
Okay, why is it negative? Because it's coming down.
But don't you throw it up?
Yeah. So if I had a positive velocity, it would be going up. If I have a negative velocity, it goes down. So that's the in reference to your positive and negativity. It's kind of cool, right?
Couldn't you also do backwards and like find, like if they give you a speed, tell how long?
Yeah. So that's called integration. So when you undo the derivative, you find the integral, and that's, we'll do that later on.
So how do you have negative?
Negative means it's going downwards.
So you just ask for
Yeah, so positive would go up, negative. Yeah, that's pretty cool, right? Okay, so here's your guys' assignment.
Oh.
Yeah, but a lot of you guys aren't going to be here tomorrow, are you?
So it's end of
So
year.
that's why I gave it a very short, there's only 10 problems. Well, 11 problems.
Can it be due Wednesday?
It'll be due on Wednesday, yeah, beginning of class.
Well, if you enjoy it,